promised, this is the first of the 4 videos that will cover the 4 problems we have done on today's class, April the 15th. Okay, this video asks to find the expression for the price given the supply and demand functions and those initial conditions. How you do it? Okay, as we have no other information, perfect market will always assume if nothing else is said, if nothing else is said, that's important. Nothing else said, we're going to assume that the demand is equal to the supply. Or 42 minus 4p minus 4p prime plus p double prime equals minus 6 plus 8p. And let's move things to the sides, to different sides. So everything that has p comes to the left. So in particular, we have that this 8p comes here and this 42 comes to the other side. All that said, we have then p double prime minus 4p prime minus 4p minus 8p equals to minus 48, which is p double prime minus 4p prime minus 12p equals to minus 48. Let me rewrite this in the way we're used in our class, which is simply rewriting the equation as y double prime minus 4y prime minus 12y equals to minus 48, and let's solve it. Remember the 4 steps we take for solving this equation. First of all is finding the homogeneous equation solution, which is y double prime minus 4y prime minus 12y equals to 0. That's what is called homogeneous. Then the particular, which is one solution of this is the same thing, equals to minus 48. Then we know our solution will be the homogeneous plus the particular. And finally, we have to use the initial conditions to find the all constant that appear in the general solution. Okay, so that's it. Start with the first step, which is the homogeneous equation. Y double prime minus 4y prime minus 12y equals to 0. We've built from here the characteristic equation. Characteristic equation is a squared because y double prime is a second derivative. So this means that we have to take a square. So a square minus first derivative a minus 12 equals to 0. So a equals to 4 plus minus the square root of 4 squared minus 4 times 1 times minus 12 square root over 2. So that becomes equals to 4 plus minus 16 minus 4 times minus 12 is equals to 16 minus with minus plus 48, which is 64. And the square root of 64 is 8. So this thing here, plus minus 8 divided by 2. 4 plus 8, 12 divided by 2 is 6. And 4 minus 8 is minus 4 divided by 2 is minus 2. Two solutions, 6, which gives e to the 60 and minus 2 e to the minus 2t. And from here we have our homogeneous solution. It's a constant, the first solution, plus another constant, the second solution. Said that, we go for the particular solution. Particular solution simply requires us, sorry for the moving up and down, to solve the same equation, y double prime minus 4y prime minus 12y, but equals to minus 48. The idea we get one solution. We don't get the solution here. YP stands for particular. Particular means one particular solution, one solution, but it's not the final solution, okay? It's not our problem solution, our problem's solution, okay? So how do we do? We always do this expression here, minus 48, we write as a polynomial in t, e to the mu t. The polynomial is minus 48. It has degree 0. So we are going to write the particular solution. We'll have, and let me change the color here to green. Particular solution will be a degree 0 polynomial, meaning a constant. E to the mu t, we don't see it. Actually, it's sort of hidden. So this is 1 or mu equals to 0. And here you get also mu equals to 0. And t to the k, we have where k is the number of times mu equals to 0 is a solution of the characteristic. But our characteristic equation has solutions given by 6 and minus 2. So mu equals to 0 is not a solution of the characteristic equation. So therefore k is equals to 0, and we get t to the 0, which is equals to 1. I should have written this in green, but anyway. We must have the particular solution double prime minus 4 times the particular solution prime minus 12y solution equals to minus 48. So 0 minus 0 minus 12a equals to minus 48. 8 equals to 4, and my particular solution is just constant 4. So third step is simply the solution to this is the homogeneous plus the particular. Go back to the video or what you have written or something like that, because you must have somewhere the h, which was a constant e to the 6t plus another constant e to the minus 2t, and the particular was equals to 4. So my solution, which I'm going to write now p, because problem was on p, p of t will be the homogeneous part plus the particular. And finally, it says use the initial conditions to find the value of C1 and C2. Our initial conditions here are P of 0 equals to 6 and P prime of 0 equals to 4. So we have to find from P, we have to find the expression of P prime. So let's write here, P is this thing here. So we write P prime of t is equals to 6c1 e to the 6t minus 2c2 e to the minus 2t. So just to put it all together and nicely, we have P of t is equal to c1 e to the 6t plus c2 e to the minus 2t plus 4. P prime of t is equals to 6c1 e to the 6t minus 2c2 e to the minus 2t. And therefore, we put now time equals to 0. And what do we have? So for time equals to 0, P of 0 by the problem's statement is 6. But if we replace in here t0, we get c1 times e to the 0, which is 1, plus c2 e to the 0, which is 1, plus 4. And P prime of 0 is equals to, by the problem, 4, but here is 6c1 minus 2c2. Therefore, we have to solve c1 plus c2. Let me move the 4 to the sign, equals to 2. And 6c1 minus 2c2 equals to 4. And to solve that, okay, so let me multiply the first equation by 2. 2c1 plus 2c2 equals to 4. And 6c1 minus 2c2 equals to 4. I add then these two equations, so I get ac1 equals to the c2 cancel equals to 8, sorry. So c1 is equals to 1. As c1 plus c2 is equals to 2, we have c2 is equals to 1, and the solution of this is c1, meaning 1, times e to the 6t plus c2, 1, e to the minus 2t plus 4. And that's the expression of the price.